To evaluate Q, the reaction quotient, and compare it to K, let's start by writing the equilibrium expression for the reaction A goes to B. A goes to B. The expression is always the concentration of products over concentration of reactants raised to the power of the coefficient, and here the coefficient is 1 for A and for B. We're told that the equilibrium constant is 10. We're also told that we have a reaction mixture that initially contains a concentration of A at 1.1 molar and B at 0.0 molar. So what does this mean? This means that the reaction mixture contains only A and no B. So this means that the reaction cannot be at equilibrium. In fact, if we were to calculate the reaction coefficient, it's the concentration of B over the concentration of A, so Q equals 0. In this case, we can see that Q is less than K because K is 10. That means we don't have, you can think of it as the system does not have enough product. There's not enough product here, which is why Q is less than K. So the system needs to produce product, more product, in order to establish equilibrium. Now we're asked to evaluate the following mixtures. The mixture contains the following. So let's write Q equals 0.1 divided by 1.0. This is 0.1. You can see that Q is much less than K. Therefore, the system is not at equilibrium. More B must be produced, more product must be produced. The numerator must get larger in order to establish equilibrium. Now let's look at B. The reaction mixture here, let's do the Q, is 1.0 divided by 0.1. In this case, Q equals K. This means we're at equilibrium. And for C, whatever it is, whatever the concentrations are, they are the same. So that means Q equals 1. And in this case, even though Q equals 1, Q is less than K because K equals 10, so equilibrium has not yet been established. So in order to establish equilibrium in the first case right here, we'll call this case number 1, the reaction must shift to the right in order to establish equilibrium. In the case of A, also the reaction must shift right in order to establish equilibrium. In B, we're at equilibrium. And in this case, C, Q is less than K, so the reaction must shift right in order to establish equilibrium. Let's say we had a situation where D, where concentration of A equals 1 and the concentration of B equals 100. So Q equals 100 over 1, Q equals 100. In this case, Q is greater than K. So you can think of this situation as the vessel contains too much product. So the reaction would have to shift left in order to reestablish or establish equilibrium.